Um, MuleSoft Architecture. Here you can see a architectural diagram of MuleSoft. MuleSoft LLC is a software company headquartered in San Francisco, California, that provides integration software for connecting applications, data, and devices. Started in 2006, the company's Anypoint platform of integration products is designed to integrate software as a service SaaS on premises software, legacy systems, and other platforms. MuleSoft's Anypoint platform includes various components such as Anypoint Design Center, which allows API developers to design and build APIs, Anypoint Exchange, a library for API providers to share APIs, templates, and assets, and Anypoint Management Center, a centralized web interface to analyze, manage, and monitor APIs and integrations. MuleSoft also offers the Mule Runtime Engine, a runtime solution for connecting enterprise applications on premises and to the cloud, designed to eliminate the need for custom point-to-point integration code. Now we are focusing on customers, partners, and suppliers. In sales, commerce, and economics, a customer, sometimes known as a client, buyer, or purchaser, is a recipient of a good, service, product, or an idea obtained from a seller, vendor, or supplier via a financial transaction or exchange for money or some other valuable consideration. A business partner is a commercial entity with which another commercial entity has some form of alliance. Supplier, a person or company that supplies goods. Here you can see a MuleSoft Accelerator for Salesforce B2C Commerce Cloud. This asset is a component of MuleSoft accelerators for Salesforce Cloud, which accelerate implementation of essential integration use cases for Salesforce Commerce Cloud. Modern consumers expect shopping experiences to be relevant, personalized, and seamless across channels. Gone are the days of bulk uploading and updating data on a weekly basis. For retailers, this means consumer products and inventory data needs to be connected in real time across all systems and channels. Here you can see products, and here you can see PIM, and products are connected to Mule here, and B2B Commerce Cloud, and also products are connected to Mule and B2C Commerce Cloud. Here you can see SAP ERP under inventory, and you can see OMS under order sync and order status, and under customer you can see SAP ERP and Service Cloud, and here products inventory, order sync and order status, and customer are connected to Mule, and Mule is Mule interact with B2C interacts B2C Commerce Cloud, and here Mule interacts order sync and order status. Here you can see MuleSoft Accelerator for Salesforce B2C Commerce Cloud solution overview. Here you can see a customer process API. The customer process API orchestrates the data flow between the experience and system API. The current release supports the following functionality: orchestrate the ordinary history records for a specific customer for a given period between Salesforce Experience API and OMS system API. Orchestrate the customer's data to be sync with SAP from B2C commerce. Orchestrate the contact data to be sync with Salesforce from B2C commerce. Contains AMQ listener for consuming customer profile data from Anypoint MQ, transform and invokes the process API. And Salesforce B2B commerce system API. The B2B commerce system API exposes product data as JSON. The current release supports the following functionality: create a product into B2B commerce, get an existing product from B2B commerce, perform product master updates into B2B commerce. The endpoint expects payloads that use the existing entities: product category, product catalog, product image, price book, and commerce entitlement policy. The entities must have been already set up in B2B commerce Lightning system before using these operations. Salesforce B2C commerce system API. Here you can see the B2C commerce API the B2C commerce system API exposes product orders and inventory data as JSON. The current release supports following functionality: perform inventory updates into B2C commerce, perform product master variant master updates into B2C commerce, perform status updates into B2C commerce. B2C commerce experience API. The B2C commerce experience API supports following functionality: new customer profile creations and updates made to existing profile in B2C commerce for storefront users and are posted through this API for further processing by the downstream APIs and implementations. Inventory process API. The inventory process API orchestrates inventory updates between SAP system API and B2C commerce system API. The current release supports the following functionality: fetch inventory updates from SAP system API and publish the records to Anypoint MQ. Point 2, next point, subscribes to inventory updates from Anypoint MQ and propagate updates to B2C commerce. PIM, Product Information Management System API. This Product Information Management PIM System API is intended to provide the means to access products data. It supports following functionality. Point 1, fetch product details based on product ID. And next point, get products and filtered by last modified date. The results are paginated using the query parameters offset and limit. Products Process API. The Products Process API syncs PIM products updates into B2C commerce. This API provides a scheduler to trigger the job and orchestrate products from product information management system to B2C commerce. This API invokes the PIM system API and B2C commerce system API. It supports following functionality. Creates or updates the products in B2C commerce using the B2C commerce system API. Get products from PIM using system API, using the system API. Salesforce system API. The Salesforce system API provides a means to access Salesforce Service Cloud application data. It supports the following functionality: query case information from Service Cloud, update case information into Service Cloud, upsert contact information into Service Cloud. SAP System API. The SAP System API fetches inventory updates from SAP. The current release supports the following functionality: fetch inventory updates from SAP to SAP for a given period. Customer data sync from B2C commerce to SAP. Order Management System OMS System API. The OMS System API supports the following functionality: create a new order in Apache of BIS, query the status of an order from Apache of BIS, fetch order history records from Apache of BIS for a specific customer for a given period. The Order Process API, new orders. This application polls the configured SFTP location for files with the name pattern orders _ YYY mmdd-hhmmss.xml containing B2C commerce exported orders and publishes the content to Anypoint MQ. All orders go into one message. The order process listener extracts each order from Anypoint MQ and calls the order process API, which then calls OMS system API to create orders in the backend OMS. Order process API order status update. The poll order status underscore fetch order status published to AMQ. Order status values for OMS, whichever it is, will not match the B2C commerce values. So values are translated as needed before updates are made. Below are the values for OF BIS reference implementation, OMS, order approved, order created, order cancelled, order completed, order hold, order payment settled, payment not received. In CC, created, new, completed, cancelled, failed. The values are mapped as shown now. In OMS, order underscore approved is matched with B2C commerce completed, and in OMS, order cancelled is matched with B2C commerce cancelled. Order completed is matching with completed. Order underscore hold is matching with failed. MuleSoft Accelerator's common services, the common components. The MuleSoft Accelerate leverage a number of common components refers to as common services. These services include following: common scheduler, unified scheduling, notification services, send notification, security services, API security policies, API template, generic implementation template. The notification and scheduler services can be configured and installed as independent applications. Notification services consist of multiple applications. Depending on which notification targets are selected, one or more security policies can be applied using API Manager. The API template project can be used to quickly create implementations for new API specifications. Here you can see B2C commerce is here, and here you can see customer in the experience layer. Here you can see custom API in the process layer, and you can see inventory, products and orders in process layer. And here you can see OMS, PIM and B2B and B2B commerce system API and SAP and contacts system layer in system layer. Here B2C commerce is connected to customer in experience layer, and a customer in experience layer is connected to customer in process layer, and it is connected to Mule in system layer, and here it is connected to Mule in system layer, and Mule is passed from this API is passed from the contact is passed from Mule to Service Cloud. Here you can see Mule in orders in process layer. Order status is passed from order status is passed from OMS to Mule, and order status is passed from Mule to Mule in process layer. And B2C commerce orders are passed from B2C commerce production to Mule API in process layer. And orders are passed from Mule to Mule in system layer, and Mule in system and orders are passed from Mule to OMS. products are orders order status is passed from Mule to Mule in system layer, and order status passed from Mule to B2C commerce production. Here you can see products in API in products layer. Product in a process layer. Here the products information, products are passed from PIM to Mule in system layer, and products are passed from Mule to Mule in process layer. Here Mule products are passed from Mule to Mule in system layer, Mule in system layers, and here the Mule is connected to B2B commerce, and products are passed from Mule to B2B commerce, and here the products are passed from Mule to B2C commerce staging. Here you can see inventory in process layer. From SAP EAP is connected to Mule in system layer, and inventory is passed from SAP EAP to Mule, and here's the Mule is connected to Mule in process layer, and here the inventory is connected to Mule in system layer. It's here inventory passed from system layer to Mule in system layer to B2C commerce production. MuleSoft Accelerator for Retail. MuleSoft Accelerator for Retail includes pre-built APIs, connectors, integration templates, and reference architecture to enable retail IT teams to jumpstart digital transformation initiatives. The MuleSoft Accelerator for Retail empowers retail IT teams to unlock data from systems including ERP, CRM, MDM, commerce, and marketing to activate digital project faster. Retail IT teams can take advantage of pre-built APIs, connectors, and implementation templates and reference architecture to create customers' 360 profiles. Shoppers expect seamless and personalized experience across retail channels. Retailers have the data, but disconnected systems prevent them from effectively leveraging the information. This portfolio of solutions helps retail IT teams to ramp up faster without needing to start from scratch. So here you can see MuleSoft Accelerator for Retail systems interact with MuleSoft Accelerator for Retail. Here you can see under systems commerce, sales, service, marketing, MDB, OMS, PIM, ERP in SAP, Azure, CDP, Marketo, and Snowflake. Outcomes interacts with MuleSoft Accelerator for Retail. Here you can see under outcomes customer profile sync, sales order sync, product syncs, real-time inventory management, and deliver relevancy with CDP. Here you can see MuleSoft Accelerator for Retail API-led diagram. um, RGB B2B Commerce System API. Accelerator B2C Commerce API. B2C Commerce System API supports the following functionality. Perform inventory updates into B2C commerce. Perform product item, master and variant creation into B2C commerce. Product inventory and category values can be assigned. Price book through OC API cannot be added. Perform product item, master and variant updates into B2C commerce. Retrieves products list using search criteria from B2C commerce. Perform order updates or perform order status updates into B2C commerce. B2C customers system API supports the following functionality. Create a customer in B2C commerce, updating an existing customer in B2C commerce. Get a specific customer from B2C commerce by customer number. Search customers in B2C commerce by global customer identifier, external customer identifier or email address. RCG MDM system API. This integration templates implements MDM system is API a system API specification. This is a system API for a master data management system MDM to manage parties, partly roles, contact points, and externals. A scaled down version of MDM has been implemented using a MySQL database. This API follows the Cloud Information Model CIM, which is also used for the MDM DB schema. This parties resource has endpoints to search parties, for example, individuals, associate contact points to a party, associate external IDs of other system to a party, and also relate a party with another party. A party can be of type individual, organization, or households. The only types of contact points that can be associated at this time are contact point email, contact point address, and contact point phone. There can also be a single instance of each type. A party can be related with other party using a relation type and can have one or more parties as part of the relation. The current implementation do not support relating households to other parties. Additional the accelerator of-biz customer system API. Of-biz customer system API provides a means to access customer person data from of-biz. This supports following functionality. Queries customer person organization from of-biz. Create customer person organization in of-biz. Updates customer person organization in of-biz. Accelerate of-biz product system API. The of-biz product system API used to manage the product's data. The current release supports the following functionality. create updates products from off-bis, searches products by product ID, master ID, retrieve a list of existing products, accelerator OMS system API. The OMS system API supports following functionality: creates updates order in Apache of bis, searches order by customer ID, external ID, order ID, and last modified date, retrieve list of existing orders. RCG's Salsify Product System API. The Salsify Product System API is used to manage the product data. The current release supports the following functionality: create updates products in PIM, Salsify, searches products by product ID, retrieve list of existing products. RCG Azure Cosmos Database System API. The RCG Azure System API can be used to manage web, email engagement, loyalty, and subscription data in Azure DB. Create web engagement, email engagement, loyalty, subscription in Azure system. Searches web engagement, email engagement, loyalty, subscription by customer ID, and last modified date. B2C commerce system API supports following perform inventory updates into B2C commerce. Perform product item master and variant creation into B2C commerce. Product inventory and category values can be assigned. Price book through OC API cannot be added. Perform product item master and variant upset into B2C commerce. Perform order status updates into B2C commerce. Retrieve promotions by promotion ID. Retrieve a list of existing promotions. RPG Marketo System API. The RPG Marketo System API can be used to send promotional marketing emails to customers, create campaigns, and schedule campaign emails to Adobe Marketo. Searches campaign by campaign ID and campaign names. RPG Salesforce CPD System API. The Salesforce CPD System API supports the following functionality: retrieve records from CPD by matching the criteria supplied for following object: loyalty, subscription, email engagement, and web engagement. Create or updates records into CPD through bulk or streaming mode for the following object: loyalty, subscription, email engagement, and web engagement. RCG Snowflake System API. RCG Snowflake System API can be used to manage loyalty, subscription, web engagement, and email engagement data in Snowflake DB. Create loyalty, subscription, web engagement, and email engagement records in Snowflake system, such as royalty, subscription, web engagement, and email engagement by customer ID, create date, and last modified date. Salesforce Customer System API. Salesforce Customer System API provides a mean to access account and contact data from Salesforce. It supports following functionality: queries customer, person, account, and account information from Salesforce. Create customer, person, account, and account in Salesforce. Update customer, person, account, and account in Salesforce. Queries contact information from Salesforce. Create contacts in Salesforce. Updates contacts in Salesforce. Queries related contacts of the given account from Salesforce. Updates account and contact relationships in Salesforce. Accelerated Salesforce Marketing API. The Salesforce Marketing System API provides a mean to access subscriber data from Salesforce Marketing Cloud, subscriber, and individual data extension. It supports the following functionality: query subscriber individual information from Salesforce Marketing, create a subscriber individual information in Salesforce Marketing, updates subscriber individual information in Salesforce Marketing. Salesforce Accelerator Salesforce Order System API. The Accelerator Salesforce Order System API fetches orders from Salesforce system. Fetch list of orders, fetch individual order, create order, patch individual order. Accelerator SAP ECG Accelerator SAP ECC System API, ECC Customer System API. The SAP ECC Customer System API can be used to manage customer data in SAP ECC. The current release supports the following functionality: creates updates customer in SAP ECC, searches customer by email, master ID, customer ID, and last modified date, retrieve list of existing customers. Accelerator SAP S/4HANA Customer System API. SAP S/4HANA Customer System API provides a means to access customer, person, organization account data from SAP S/4HANA. It supports the following functionality: queries customer, person, organization account information from SAP S/4HANA, create customer, person, organization information account in SAP S/4HANA, updates customer, person, organization account in SAP S/4HANA. Accelerator SAP S/4HANA Orders System API. SAP S/4HANA Order System API fetches orders from a SAP S/4HANA system. it allows you to fetch a list of orders, fetch an individual order, create order, patch individual order. Accelerator SAP S4HANA Product Availability System API. The SAP S4HANA Product Availability System API fetches product availability from SAP S4HANA system. It allows you to fetch product availability. SAP S4HANA Product System API. SAP S4HANA Product System API fetches products from a SAP S4HANA system. It allows you to fetch list of products, fetch individual products, create products. Accelerator Customer Process API. The Customer Process API orchestrate the data flow between different systems. The current release supports the following functionality: orchestrates customer profile data to be synchronized from B2C commerce. Salesforce, SAP, Offbiz, and to MDM and downstream systems. Orchestrates customer contact data, contact point, email address to be synchronized from B2C commerce, Salesforce, and SAP to Salesforce Marketing Cloud. Orchestrate individual data to be synchronized between Salesforce and Marketing Cloud and to MDM. Orchestrates organization data to be synchronized from Salesforce and SAP to MDM and downstream systems, not Salesforce Marketing Cloud. And B2C commerce do not support organization data. The Accelerator ERP Customer Process API. The ERP Customer Process API is used to manage customer data. Current release supports the following functionality: creates, updates customer individual in SAP ECC and individual organization customer in SAP S4HANA, searches customer individual by email, master ID, customer ID, and last modified date, retrieve list of existing customers, polls the recently updated or created customer individual in SAP ECC and publishes to the queue to sync across all systems. ERP Order Process API updates order. ERP Order Process API is used to manage the order data. Currently supports the following functionality: updates order in SAP S4HANA, Searches order by order ID, external ID, and customer ID. Retrieve list of existing orders. The inventory process API supports the following functionality. Get inventory availability from SAP S4 HANA to B2C Commerce Cloud or B2B Sales Cloud Service. Also asynchronously update inventory in B2C. The accelerator order process API. The order process API orchestrates the data flow between different systems. The current release supports the following functionality. Orchestrates orders data to be synced from B2C commerce or Salesforce core to MD and downstream system like Salesforce, SAP, S4HANA, and OffBiz. Orchestrates orders created in B2C commerce or Salesforce core. Status sync from SAP S4 HANA to MDM, B2C commerce, Salesforce, and OffBiz. Accelerator PIM sync process API. PIM sync process API loads products from the system of records to the PIM database. It also pulls products modified using last updated time and pushes the updated data to the queue for downstream systems. It supports following functionality. Loads all products from system of records to the PIM database. Gets updated products from the PIM database. Publishes the updated products to the queue. RPG product process API. This integration template implements RCG product process API specification. It can be used to retrieve, create, and update products. RCG customer data platform process API. The RCG CDP process API can be used to sync data of Snowflake, loyalties, and subscription, and assure email engagement and web engagement with Salesforce CDP. The implementation supports AMQs to push the data to RCG Salesforce CDP system API. Send customer profiles for loyalty, subscription, web engagement, email engagement to RCG Salesforce CDP system API. RCG Data Lake Process API. The RCG Data Lake Process API can be used to sync data from Snowflake and Azure data lakes. The implementation supports schedules batch jobs as well as manually triggered batch jobs. This API also receives published CDP segments from AWS S3. Publish customer profiles for loyalty, subscription, web engagement, email engagement to RCG Data Lake Exchange, Anypoint Queue Exchange. Retrieves and publishes CDP segments to RCG Marketing Exchange, Anypoint Queue Exchange. The RCG Marketing Process API. The marketing process API listens to the campaign creation and updates events from Anypoint MQ and orchestrates the creation and updates to B2C and B2C system. This API uses the MDM system API to retrieve the current customer information, customer ID of respective system to create a campaign for that particular customer in B2C and Marketo. Creates or updates the campaign in Marketo and B2C. Searches a campaign for campaign ID, customer ID. Retrieve a list of existing campaigns. B2C accelerate the B2C commerce experience API. This the B2C commerce experience API supports the following functionality: the new customer profile creation and updates made to existing profile in B2C commerce for storefront users are posted through this API for further processing by the downstream APIs and implementations. A new customer orders created in B2C commerce are posted through this API for further processing by downstream APIs and implementation. Get real-time inventory products per store in B2C commerce from SAP S4HANA. Accelerated Salesforce Experience API. The Salesforce Experience API displays OMS data as JSON. The current release supports the following functionality: displays order history records for a specific customer in a given period of feeder from OMS system API. Displays inventory of the product in the associated stores. Salesforce marketing accelerator Salesforce marketing listener. The solution includes pre-built APIs, connectors, and integration systems to help unlock business critical data from external systems. These templates provide details of how Salesforce marketing system API handles events and in case of creation new subscribers and how those events are processed in to message exchange. The message posted to exchange will be in a cloud information model CIM format, which will be processed by customer process API. Salesforce accelerator Salesforce topic listener. The Salesforce topic listener application supports the following functionality: listeners for case event from Salesforce push topic, converts events payloads to CIM and publishes it to Anypoint MQ. Listen a customer person account and account events from Salesforce push topic, converts the event payloads to CIM and publishes it to Anypoint MQ. Listen for contacts events from Salesforce push event, converts the event payload to CIM and publishes it to Anypoint MQ. Listen for opportunity events from Salesforce push topic, converts the event payload to order CIM, creates an order in SAP HANA and publishes the order CIM to Anypoint MQ. Listen for order from Salesforce platform event created by the order trigger, converts the event payload to order CIM, publishes the order CIM to Anypoint MQ, which then creates the order in SAP S4HANA. RCG SAP S4HANA event listener. The SAP event listener application supports the following functionality: listen for order events from SAP HANA. SAP S4HANA, converts the event payload to CIM and publish it to Anypoint MQ. Listen for customer person account events from SAP S4HANA, converts the event payload to CIM and publishes it to Anypoint MQ. Listen for the product events from SAP S4HANA, converts the event payload to CIM and publishes it to Anypoint MQ. Listen for purchase order acknowledgement events from SAP S4HANA, converts the event payload to JSON. And send it to Anypoint Partner Manager. Listen for shipping notification event from SAP S4HANA, converts the event payload to JSON and send it to Anypoint Partner Manager. Listen for invoice events from SAP S4HANA, converts the event payload to JSON and send it to Anypoint Partner Manager. RCG Salsify Channel Listener. The Salsify Channel Listener application supports the following functionality. Listen for products events from Salsify, converts the event payload to CIM and publishes it to Anypoint MQ. There are custom component. The Accelerator B2C plugin install pickup cartridge. This plugin enhances the app storefront base cartridge by providing buy online pickup in store functionality, including following capabilities. Shoppers can search for stores by geographical radius. Shoppers can check the real-time inventory from SAP S4HANA system by providing the zip code and within radius. Shoppers can select the store for pickup. Shoppers can change the selected store by initiating another search. Shoppers can purchase multiple products and have different products delivered to different addresses, including to a store. Shoppers can review their order histories to see where orders are delivered. Shoppers can review order receipts and summaries to see where products were delivered. Accelerator B2C commerce sync cartridge. The customer profile sync cartridge is used to detect when customer profile is created and updated in Salesforce B2C commerce and invoke an API for further processing for customer profile data in real time. Accelerate ID graph LWC. The Lightning Web Component LWC can be used as the front end for displaying data from API delivered with Mule. This LWC displays a networking graph relating to a source record in Salesforce as a root node to n number of systems as child edge nodes. This LWC is written generically to support any parent-child relationship as a network graph. Accelerator POM parent. The Accelerator POM parent project is used for storing common configurations, constant common dependencies, and resources used across all child projects. It provides a single Maven configuration file, POM, which is used as a parent by most other Accelerator projects. Accelerator product availability LWC. Lightning Web Component LWC can be used as a UI for displaying data from APIs delivering with Mule, which displays an inventory check button to perform an available to promise check against ASAP. Is written generically to support inventory check and update available quantity, product ID, and location. And there are common services can be used across any use case. MuleSoft Accelerator's common services. The Mule Accelerator leverage a number of common components refers to as common services. These services include following: common scheduler, unified scheduling, notification services, send notifications, security services, API security policies. The notification and scheduler services can be configured and installed as independent applications. The notification services consist of multiple applications depending on which notification targets are selected. One or more security policies can be applied using API Manager. Here you can see System API. Under System API you can see SAP Custom API, Sales Service Custom API, Marketing API, B2C Commerce API, MDM DB API, OMS API, Sales Service Order API, ERP Order API, Sales Service Product API, PIM API, SAP Inventory API. In Process APIs you can see Salesforce Topic Listener, Salesforce Marketing Listener, Custom API, Order Process API, SAP S4 Event Listener, ERP Order Process API, Product Process API, PIM Sync Process API, Real-Time Inventory API. In Experience API you can see B2C Commerce API and B2B Commerce API. Here you can see CRM, Marketing, B2C, B2B Commerce, ERP Order Update Service, and here you can see MDB, OMS, PIM. Here you can see SAP Customer API is connected to Customer API and Sales Custom API and Marketing API, B2C Commerce API, and MDM DB API are connected to IPS interacts with Customer API. Customer API in Process APIs interact with Salesforce Topic Listener and B2C Commerce API in Experience API, and Salesforce Topic Listener is connected to CRM here, Salesforce. Here MDM DB API and B2C Commerce API and OMS API and Sales Service Order API APIs interact with Order Process API. Order Process API interacts with ERP Orders Process API, SAP S4 Event Listener, and B2C Commerce API in Experience API and B2B Commerce API and B2C Commerce API, and B2B Commerce API is connected to API interacts with B2C Commerce, and here B2B Commerce API interacts with B2B Commerce. Here ERP Order API interacts with ERP Orders Process API, and ERP Orders Process API interacts with Order Process API. Here Salesforce Marketing Listener interacts with Marketing, and SAP S4 Event Listener interacts with Order Process API and SAP and ERP Order Updates. Here ERP Order API and OMS API and MDM DB API and B2C Commerce API and Sales Service Product API interacts with Product Process API, and Product Process API interacts with PIM Sync Process API. Here PIM API interacts with PMI Sync Process API, and PIM Sync Process API interacts with Product Process API, and SAP Inventory API interacts with SAP Inventory API, and B2C Commerce API interacts with Real-Time Inventory API. Real-Time Inventory API interacts with Service, B2C Commerce, and CRM. Here, as an example, you can see BAPI custom object structure, BAPI str inventory data in here, inbound inventory data, short description, and you can see the other information here. As an example 2, we can consider MuleSoft Accelerator for Retail API Client ID settings. OpenID Connect allowed scopes. You can see here sfcc.orders, sfcc.customerlists.rw, etc. Now we are focusing on cloud platforms. The hardware and operating environment of a server in an internet-based data center. The system software components, OS, virtual machine monitor, etc. are called the cloud stack. The software infrastructure for a cloud computing service, which includes applications that let users create and manage their own accounts. As an example, we can consider OpenStack. OpenStack is a free, open standard cloud computing platform. It is mostly deployed as Infrastructure as a Service, IaaS, in both public and private clouds, where virtual servers and other resources are made available to users. The software platform consists of interrelated components that control diverse multi-vendor hardware pools of processing, storage, and networking resources throughout a data center. Users manage it either through a web-based dashboard, through command line tools, or through RESTful web services. As example 2, we can consider here you can say Amazon Web Services. Amazon Web Services Inc. AWS is a subsidiary of Amazon that provides on-demand cloud computing platforms and APIs to individuals, companies, and governments on a metered pay-as-you-go basis. These cloud computing web services provide distributed computing processing capacity and software tools via AWS server farms. One of these services is Amazon Elastic Computing Cloud, EC2, which allows users to have at their disposal a virtual cluster of computers available all the time through the internet. AWS's virtual computers emulate most of the attributes of a real computer, including hardware central processing unit, CPUs, and graphics processing units, GPUs, for processing, local RAM memory, hard disks, SSD storage, a choice of operating systems, networking, and preloaded application software such as web servers, databases, and customer relationship management, CRM. As an example 3, we can consider parameter connection. The connection types to provide this. The connection types to provide to this configuration. Azure Service Bus Azure Service Bus Connector 3.2 Mule 4. Anypoint connector to this is a Anypoint connector for Azure Service Bus. Azure Service Bus connector enables message integration with Azure Service Bus on the cloud. Now we are focusing on Saas, software as a service. Saas is a software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted. Saas is also known as on-demand software and web-hosted software. As an example, we can consider this operation. SAP Concur connect dash connector colon create dash report. This is related to SAP Concur connector 4.2 Mule 4. Anypoint connector for SAP Concur Concur connector is a SaaS provider from SAP for integrated travel and expense management solution. As an example, we can consider example 2. We can consider Magento connector Mule 3. Magento connector Mule 3 enable instant API connectivity with the Magento e-commerce platform with the Magento connector, making it simple to manage e-commerce storefront, shopping carts and inventory. As an example 3, we here to install the box connector in Anypoint Studio, follow these steps. Open Anypoint Studio and go to help, install new software, select Anypoint connectors, update site to http://repository.mulesoft.org/connectors/releases/3.5.0. locate the step 2, locate the box connector. Step 3, click next and accept the license agreement. Step 4, restart Studio when prompted. Here the box we are regarding here box connector 5.1 Mule 4. The Anypoint connector for box is a closed source SDK based connector that provide synchronization of data and automation of processes between box and third-party CRM, CMS, mobile and social applications. Now we are focusing on social. Social of a group of people, an organization, etc., consisting or composed of people associated together for friendly interaction or companionship. As an example, we can consider the message processor LinkedIn get profile by LinkedIn get profile by ID. This gets the profile by ID. Here the with regarding LinkedIn connector Mule 3, this is under LinkedIn connector Mule 3. Find top talent faster through LinkedIn by creating connectivity between the professional social networking site and popular third-party applications and services with MuleSoft Anypoint LinkedIn connector. Anypoint connector gives businesses the power to connect to numerous LinkedIn APIs, including job, share, groups, invitation, profile, and more, to create seamless integration across applications and services. This is in org.mule.modules. Here you can see the attribute ID, the ID to search, and this is a string. And here you can see child element, blinking colon profile dash fields. This is optional, and the profile fields to retrieve. Here you can see the fields to retrieve, and this returns return type is person, profile by ID. As an example too, we can consider this message processor Facebook colon like. This write to the given profiles feed or wall. The Facebook connector this is related to Facebook connector Mule 3. It provides businesses with instant Facebook API connectivity, allowing them to easily integrate the social networking service with other applications such as Twitter, Drupal, and Salesforce, or extend the application capability to applications by leveraging Facebook connector. This is in Mule org.mule.modules here, and here you can see attribute post ID. This represent the ID of the post object, and this message processor returns return type is boolean, and it returns true if successfully liked. Here as an example 3, to use this Mule module Facebook within a flow, the name is space to the Mule must be included. The resulting flow will look similar to the following. The Mule module LinkedIn the Mule module Facebook. The Facebook is a social networking service and website launched in February 2004. This is in org.mule.modules. Here goes your flows and configuration elements. This module is configured using the config element. This element must be placed with outside your flows and at the root of your Mule application. You can create as many configurations as you deem necessary, as long as each carries its own name. Error handling during authorization. If for any reason an error occurs, while processing the callback, the exception strategy of the flow containing the authorized will be executed. So if the callback sent the wrong information, you can handle the situation by setting up an exception strategy as follows. This is in the environment with Mule LinkedIn connector. Now we are considering mobility and devices. Mobile computing is a human-computer interaction in which a computer is expected to be transported during normal usage, which allows for a transmission of data, voice and video. Mobile computing involves mobile communication, mobile hardware and mobile software. Communication issues include ad hoc networks and infrastructure networks, as well as communication properties, protocols, data formats, and concrete technologies. Hardware includes mobile devices or device components. Mobile software deals with the characteristics and requirement of mobile applications. Computing device, a functional unit that can perform substantial computations, including numerous arithmetic operations and logic operations without human intervention. It can also be a device that provides a specific set of functions, such as a phone or a personal organizer, or more general functions such as a laptop or desktop computer. As an example, we can consider HTTP endpoint coupled with a REST component. The first step in communicating with the mobile application would be to use an HTTP endpoint coupled with a REST component. This step takes care of most of the complexity associated with communicating with your mobile apps and consuming JSON objects. Now we are focusing on APIkit, Anypoint API Manager and APIhub. APIkit, Anypoint API Manager and APIhub. Now we are focusing on APIkit. APIkit is a tool for building Mule, REST or SOAP APIs. You develop APIs based on one of the following modeling languages: RESTful API modeling language, RAML 1.0 and 0.8 versions, Web Services Description Language, WSDL. APIkit simplifies the design and implementation of REST APIs. APIkit generates minimal Mule flows based on either RAML or WSDL that meet the communication operations required by a REST or web service contract, respectively. In Studio, the REST APIkit project looks like this. This is the REST API in Anypoint Studio UI with Package Explorer and Canvas sections. Here 5 items illustrated here show one here the project files in the package explorer of Studio with the API dot RAML file under here under here API.RML file under src/main/resources then API folder. Number 2, here the main flow with the APIkit router. Here number 3, the APIkit console. Number 4, error handling, and number 5, the generated flows for each resource method. The generated minimal flows meet the communication operations required by a REST contract. Here in Studio, the SOAP APIkit project look like this. This is a SOAP API in Anypoint Studio UI with the package explorer and canvas sections. The 4 items illustrated here shows number 1 here the project files in package explorer of Studio with the example.wsdl file under src/main/resources/API folder. Then number 2, the main flow with the SOAP router. Number 3, SOAP fault response template. Number 4, generated backend flows containing SOAP message templates. After you create your APIkit project, you can continue building the application by performing calls to test API and finalize its implementation. Here as an APIkit anatomy, the REST or SOAP Studio project uses APIkit has following part: REST or SOAP interface, main flow and backend flow. Here we are considering REST Studio project here. In the REST interface, relationship between REST resources and actions are called resource action pairing. The interface exposes the internal data assets requested by the REST service. Also, the interface define API designating resources that contain no access data and specify actions such as get and put on the example data. Here you can see API console interacts with RAML. Here you can see the API main, API console, and API config. Here this is flow 1, this is flow 2, and here you can see http:/listener-config and APIkit colon config, the main, then flow, name equal API main, etc. And you can see here APIkit colon router. Here you can see a SOAP Studio project. In the SOAP interface, the interface defined by a WSDL file exposes a number of services. Each service has a set of operations. The underlying type of data is XML, defined by schemas within WSDL file or by an imported XSD file. Here you can see SOAP UI interacts with WSDL, and here you can see API main here, the SOAP route is here, and SOAP kit-config here. Sorry, API SOAP kit-config is here, and SOAP kit-config is here. This is flow 1 and this is flow 2, and here you can see http colon listener-config APIkit SOAP colon config, and flow name API main, etc. Here you can see a REST API main flow. The main flow for RAML based API manages these functions, exposes the API using HTTP or Jetty, routes request between the interface and the backend flows based on HTTP request, routes reference exception strategies that produce HTTP status code responses. The APIkit router tasks include routing messages, serializing responses, and validating payloads, headers, query params, and URI params. Message routing consists of routing incoming API requests to existing Mule flows and returning outgoing HTTP response codes to exceptions. Here you can see HTTP is connected to APIkit router, and APIkit router is connected to here, and you can see the reference exception strategy here. Here you can see SOAP API main flow. The main flow for WSDL based API managers the first two tasks. The logic in the main flow accepts requests, sends responses, and facilitate communication between interfaces and API process. The main flow typically consists of HTTP listener and SOAP router components. Here you can see /t-shirt service /t-shirt service port. It's there, and it's connected to SOAP router, and it is connected to here, and you can see the error handling here. Here you can see the how APIkit works with RAML. The following diagram shows how a RAML based API built by APIkit processes end user request. Here in step 1, you can see the end user sends HTTP request to API. In step 2, the HTTP or Jetty endpoint in the main flow receives the request and passes the message to APIkit router. In step 3, the router checks with the interface to confirm that the resource action pair exists in the interface. Step 4, here the router checks where to see if a body is defined as part of the request. Generally, a request sends a body with put, post, patch requests. In step 5, if the request includes a body, the router determines the media type associated with the body, then matches the request content type with the one defined in the interface. In step 6, if a schema is defined for the content type, the router checks that the schema on the incoming request matches the schema defined in the interface. If the schema is not valid, the application rejects the request. In step 7, the router uses the information contained in the interface to determine which backward backend flow should receive the request. For example, based on the request and the resource action pairing, the router determines what it should send the request to flow 2. In step 8, router send the request to flow 2. In step 9, the flow 2 process the flow 2 processes the request, accessing a resource and acting upon data as required. In step step 10, flow 2 returns a response to the router. In step 11, the router pushes the response to the HTTP or Jetty endpoint. Step 12, the HTTP or Jetty endpoint sends the response to the end user. And step 13, from the console, you can simulate API calls by submitting requests through the web user interface. Here you can see single Mule Studio project. Inside it you can see RAML API definition, end user, and config.xml. Here interface.raml. So interface.raml interacts with config.xml, and config.xml interacts with end user. Single Mule here single Mule Studio project here. In config.xml you can see APIkit colon config is there, and exception is set there, and flows are here. and config.xml interacts with Anypoint platform private cloud edition or on cloud storage, and you can see the console here. The console interacts with a single Mule Studio project, and here you can see get, and here you can see post request, and here response in console. As an example, we can consider create a new project, new APIkit project. This procedure launches the new project and generate a main flow with an HTTP listener and an APIkit router and references to flows to handle errors. The project supports REST resources and methods. These flows, called skeleton flows, are the bare minimum structure needed to support the RAML specification. The RAML files imported by this procedure is located at src/main/API. Step 1, download the example file to your local drive. Step 2, from the file menu, select new, then Mule project. Step 3, in the new Mule project wizard, enter a project name, my project for example. Mule server 3.8.0 will be selected by default in the runtime section. And step 4, check add APIkit components. Step 5, in the APIkit settings section, select the downloaded api.raml example file, and step 6, click finished. Here you can see a screenshot of step 5. So here in the APIkit settings section, select the downloaded api.raml example file here, and if you run the project, for example, API returns a list of machines. The output is the payload set on the message by get :/machines :API config flow. This is a sample output here. As an example 2 in XML, we can consider the APIkit element here. So here APIkit config, the APIkit configuration. This is a required one, and here you can see APIkit namespace and schema. Namespace and schema locations. As an error example, you can consider this one. This code snippet, in APIkit 4.0 replaces the exception strategy and error mapping with the Mule runtime 4.0 error handler. This error handler uses error types as shown in this snippet here. Each error response is generated using data view. Here you can see APIkit bad_request type. The status code is 400, and the message is bad request here. Um, Now we are considering Anypoint API Manager. Anypoint API Manager is a component of Anypoint platform that enables you to manage, govern, and secure APIs. It leverages the runtime capabilities of API Gateway and Anypoint Service Mesh, both of which enforces policies, collect and track analysis data, manage proxies, provide encryption and authentication, and manage applications. Here you can see what API Manager looks like. To access API Manager, log into Anypoint platform and select API Manager from the main menu. Here in one you can see the environment selector. Anypoint platform enables you to create and manage separate deployment environments for APIs and applications. API Manager displays all environments except design environments. Number 2, navigation menu. In API groups, an API group is an API asset that enables the organizations to publish a group of API instances as a single unit. Automated policies. Policy automation enables security architects and administrators to secure and govern every API running in an environment. Client applications. Applications are external services that consumes APIs. Custom policies. Custom policies are policies that anyone can develop and apply to their APIs with the intention of extending existing functionality or defining new functionality. Data graph administration. Anypoint data graph enables you to unify all the data within your application network in a unified schema. Analytics. API analytics provide insight how your APIs are being used and how they are performing. Number 3, API add API button enables you to add a new API instance to promote an API from any environment to the current environment. Or to import a configuration zip file that was exported from API Manager. For the environment information button, available only to administrator users, enable administrators to display a dialog with information about the current environment, such as environment credentials. Use environment credentials to provision the Anypoint Service Mesh adapter or to configure Studio to sync with your environment. Number 5, search. Search enables you to search for managed APIs using API search field. Searches are case insensitive. Filter search results by selecting active. Number 6, tracking the registration status of each API, active, inactive, or unregistered. The status of unregistered means that Anypoint platform has never tracked the endpoint for this API version. Either you have entered a URL for an API or proxy that hasn't yet communicated with the platform, or you have declared an endpoint that is hosted somewhere other than an API gateway, or and need to proxy that endpoint so that the platform can track it. The endpoint must have a tracking registration status of active for governance policies and SLA tiers to function. SLA tiers to function. Now 7, the name of each API. Clicking the API names navigate you to the API settings view, where you can manage the following alerts, contracts, policies, SLA tiers. 8, percentage of API requests that resulted in errors. If no data is displayed, automatic monitoring has not been enabled for the API. 9, the total number of API requests in the past 24 hours. If no data is displayed, automatic monitoring has not been enabled for the API. Number 10, the number of contracted client applications for each API. Here you can see API administrator sandbox and sandbox API administration, API groups, automated policies, client applications, custom policies, data graph administration, analytics. In the main, here you can see the status, API name, label, version, instance, error rate, total request, client application, and creation date. Here you can see API gateway capabilities. The runtime, the Mule runtime includes an embedded API gateway. Using this gateway, any user can, for example, apply a basic authentication policy on top of a Mule application, enrich an incoming and outgoing messages, or add any other complex capability to an API without having to write any code. Overall API gateway allows you to add a dedicated orchestration layer here on top of your backend APIs and services to help you separate orchestration from implementation concerns. You can leverage the governance capabilities of API Manager to apply, among other capabilities, throttling, security, caching, and logging to your APIs. Here you can see API Manager is connected to Anypoint runtime manager agent. Governance enforce is passed from API Manager to Anypoint runtime manager agent. In Mule runtime engine, you can see the API gateway is there, and backend APIs here, and you can see here orchestration layer and implementation layer. Clients are connected through API gateway here. Actually, clients interacts with API gateway, and API gateway interacts with backend API, and endpoint is interact between clients and API gateway here. Here you can see Anypoint service mesh architecture. Anypoint service mesh enables you to extend your microservices network by including your non-MuleSoft applications into the platform. Platform sphere. You can then manage and secure your application network, including your non-Mule applications seamlessly from a single pane. Your non-MuleSoft microservices might be written using different languages and platforms, or might be deployed in different environments. To alleviate issues arising from differences in these microservices, Anypoint Service Mesh ensures the following application management advantages. Provides resilient service-to-service communication using zero trust policies to handle traffic control, fault tolerance, and load balancing. Extends MuleSoft API management capabilities to any non-Mule service with policies, security, and analytics all applied directly from Anypoint platform. Amplifies reuse of services with discovery of non-Mule services within Exchange available for use in future projects. Here, Anypoint Service Mesh Architecture. Anypoint Service Mesh Architecture. Anypoint Service Mesh is an independent architecture layer encapsulated in Kubernetes or Red Hat OpenShift cluster. In the Anypoint Service Mesh architecture, instead of services directly communicating with one another, a sidecar proxy is used to perform the same job. The sidecar proxy enables you to bring your existing non-Mule microservices from the Kubernetes cluster as API into Anypoint platform. You can manage these APIs within API Designer, API Manager, and Exchange. Additionally, you can monitor the health of your APIs using API Analytics. Because of the mixer component is deprecated in Istio version 1.5 and later, the authorization mechanism aspect of the mixer is now implemented by leveraging Anypoint Service Mesh envoy filters. With the envoy filter, requests are sent directly to the adapter, thereby minimizing additional processing. As illustrated in this diagram, at the top of the architecture is Anypoint platform, which brings complete lifecycle API management capabilities to the microservices built with Mule runtime engine. Mule. These Mule instances might be deployed within CloudHub or Runtime Fabric at your location. Istio, which is installed on a Kubernetes cluster, uses Envoy to manage services by using a sidecar proxy. The sidecar is responsible for any communication with your service and resides within the same container as that service. With Anypoint Service Mesh enabled, you can continue to use Istio's native policies for traffic control and security. The MuleSoft adapter connects components to Anypoint platform. Along with the broker, The adapter enables all services that are managed by the mesh to share metadata, which in turn enables your existing microservices in the Kubernetes cluster to be recognized as APIs by Anypoint platform. After services are discovered, Anypoint Exchange uses the metadata to automatically discover and create APIs, HTTP, REST or SOAP for each service. These APIs can then be managed within API Manager. Similarly, Anypoint monitoring uses the metadata to get information from the sidecar proxy and makes it available for API analytics. Here you can see Mule applications. Under that you can see Cloud Hub and Runtime Fabric. You can see Mule apps are in Cloud Hub and Mule apps are in Runtime Fabric. And these applications, Mule applications connected to Anypoint platform. And here you can see Kubernetes cluster or Red Hat OpenShift. You can see here Istio under that, and under Istio you can see Mule adapter, and here you can see service A is connected to sidecar proxy, and service B is connected to sidecar proxy, and sidecar proxies are interacting each other, and Kubernetes cluster Red Hat OpenShift is connected to Anypoint platform. API-led connectivity for microservices. You can see discover, manage, and secure inside API platform, and internal and external APIs are APIs are on top of Anypoint platform here. This is related. We can consider this as an example. Add a new API, adding an API instance. After you have created an API using Design Center or any other application, you can then manage that API in API Manager by adding an API instance. There are 3 options for adding API instance. Add a new API, like here. Select this option to add a complete new instance of an API, or promote API from environment, and import API from a zip file. Here we are considering add a new API. Step 1, log onto Anypoint platform. Step 2, in the navigation bar or the Anypoint platform page, click API Manager. Step 3, click Add API and select Add New API. Step 4, select and configure your runtime from the following options. API Flex Gateway. Select Flex Gateway for any APIs that need a flexible, performant API gateway that will work with distributed and microservices environment and fit into your CI/CD environment. Choose the connected Flex Gateway you have installed and registered from the list under the Select Gateway. Note, if you do not see a Flex Gateway listed, or you see a Flex Gateway but its status is disconnected, go for documentation related to install Flex Gateway or register and run in connected mode for more information. Mule Gateway. Select the Mule Gateway if you have an API on Mule runtime that need an API gateway to manage, observe, and secure your APIs. Select proxy type from the following options. Connect to existing application basic endpoint. Use this option directly interact with your Mule runtime engine Mule application where your application is configured with API gateway auto discovery. select the Mule version. Next point, deploy a proxy application. Use this option to interact by proxy with an application, either because it is Mule application not configured with API gateway auto discovery, or because it is not a Mule application. Here select target type from the following options. CloudHub. Select CloudHub if you want to use the Mule runtime hosted on the cloud by MuleSoft. The CloudHub proxy includes a CPU with 0.1 vCores and a memory of 500 MB by default. Select the runtime version, enter a proxy app name. Option 2 is next option, hybrid. Select hybrid if you have a Mule runtime running on an on-premises server that you want to use. Note, if you are running an API with self-managed server, use classic API creation flows to manage your API. Select target from the list or click add server. Enter a proxy app name. Service mesh. Select service mesh to extend Anypoint platform API management capabilities to your Istio service mesh through the endpoint of a Mule adapter. Note, after adding the API on Anypoint platform, you will need to bind it to a service using the Anypoint service mesh client. Click next. 6. Select an API from the following two options. Click select API from Exchange if you have an API shared with you through Exchange that you want to manage. Step 1. Click the API from the list under select API. You can search for a specific API if needed. Update. Step 2. Update asset type, API version and asset version if needed. Point 2. Next point, click create new API. Enter a name for step 1. Enter a name for the new API asset. Step 2. Select the asset type from the following option. REST API. Select REST API if you have an RAML or OAS API definition file you want to include for your asset. Upload either RAML or OAS file for your REST API. HTTP API. Select HTTP API if you do not have an API definition file you want to include your asset. SOAP API. Select SOAP API if you have a WSDL API definition file or an external link to the file. Upload the WSDL file for your SOAP API or add the link to the file. This option is not available for Flex Gateway runtime at this time. Step 3. Optionally, you can add an asset ID and customize the version or API version details by clicking Advanced. Step 7. Click Next. Step 8. Configure the endpoint and other settings. Enter the implementation URI for this API. The implementation URI is the URL to access the proxy or the API. For example, you can use the URL of your API asset in Exchange. This is the only required field. Next point, update the other fields if needed. Step 9, click Next. Step 10, review your selections. You can edit search section if necessary. Step 11, if you are ready to deploy, click Save and Deploy. Otherwise, you can select Save to save the API instance and deploy it at a later time. With related to configure an API instance on Flex Gateway options, we can consider the field name implementation URI, the URL to access for the proxy or the API. It must end with a forward slash. This is a required one, and and notes. For example, you can use the URL of your API asset in Exchange. As an error example, we can consider this one: entitlement required. Account is not entitled to use API Manager. Contact your organization administrator for more details. Now we are focusing on APIhub or API portal. API portals are bridges between API providers and API consumers that provide information about the API at every stage of an API's lifecycle. API portals allows providers to expose and publicize their APIs, educate developer communities about them, provision user access, generate client keys, and more. For API consumers, API portals are the place to register applications, reset credentials, share and interact with API documentation, provide feedback about the quality of the API, and report bugs. Here you can see the 3 API lifecycle stages. Basically, what is full lifecycle API management? As API adoption increases, their usage continues to spread across all areas of the business, but APIs alone are not enough to meet the rising integration challenges of today's digital world. Organizations must give their API programs first-class treatment with the full lifecycle API management solution. Enabling developers with an API management solution across full lifecycle of that API provides them with the flexibility and adaptability necessary to integrate application systems and data in an evolving environment. Full API lifecycle management is the process of overseeing an API from its creation to retirement across its full lifespan. This includes everything from designing, publishing, documenting, securing and analyzing APIs. An effective API strategy must include an API management solution that makes APIs easily discoverable and reusable and ensures that they are properly governed and secured. At the core of the API management is the need to survive the full lifecycle of an API and enable the associated ecosystem. An API first approach emphasizes the importance of the entire lifecycle by strategically treating APIs as a product and managing them as such. The outcome of this approach is well-designed, managed, and secured API to serve developers building a new experiences. Below are the 3 distinct stages of this product-centric life cycle: design, implementation, and management. Design. The first step in the API lifecycle is design. When the API is created, the designing an API start with the outside in the perspective, beginning with the interface contract of the API. API developers create the user interface of API first, determining how the API looks and behaves. This is also known as the API contract. This approach is typically referred to as design first approach and should follow a deliberate API design lifecycle to optimize for the best experience. This step must be done in a human readable fashion. To specify the contract in a way that developers can easily digest. Within this step, developers perform these tasks: design, identify the process and business requirement, create logical data model, translate into logical service, API groupings. Simulate, model API resources, model API operations methods, model request response payload codes. Feedback, mock up the API, publish interactive console, create notebook use cases, receive developer feedback, invalidate, modify API design as appropriate based on the developer feedback. Continue to validate. Any well-designed API will have repeatability across other APIs. This can easily be encapsulated into best practice patterns both at the structural level of the API, nouns, resources, as well as at the method level, verbs. So as API developers go about the design process, it is important that they can discover and share repeatable patterns. Implement. The API implementation is a crucial piece of enabling next generation enterprise, enabling the continuity of hundreds or thousands of APIs to a backend as well as to each other key. This must be done in a systematic manner as opposed to point-to-point code. The two steps that go into the implementation stage are building and testing. A systematic approach to building ensures that the API developer has the following architectural patterns easily available to them: orchestration, transformation, routing, data mapping, and connectivity across systems. Once the API is built, it will go through rounds of API testing to ensure that it is functioning as expected. If the testing is completed with no problems, you can move on to the next lifecycle stage. But most often the API will go through several rounds of testing and adjusting before moving on to deployment. Test automation tools are critical here, as this integrates onto the DevOps processes of continuous delivery and deployment. Management. It is critical to ensure your application building blocks are following the best practices in security and architectural governance by applying policies to them at runtime. Monitoring all traffic via an API manager is equally critical because it just takes just one weak link to bring the ship down. Within this lifecycle stage are the following steps: secure, deploy, monitor, troubleshoot, and manage. Additionally, these APIs need to be discoverable to be reused for other purposes. The ability to appropriately publish them so the consuming developer can find, research, and understand them easily could make or break your entire program. So here you can see steps. The first step is design. Under that you can see this task: design, simulate, feedback, validate, and let's go to the API specification. It is connected to the API specification then. The next step is implementation. Here you can see two steps: build, and then build is connected to test here. and test is connected to service with API. And here you can see next step, management. CQI is connected to deploy, and deploy is connected to monitor, and monitor is connected to troubleshoot, and troubleshoot is connected to manage, and go through likewise. Here you can see meet Anypoint. You can see the Anypoint exchange here. Anypoint exchange is the global repository for all technical assets in an API or Mule application's lifecycle. It is a central hub for saving, discovering, and collaborating on reusable assets such as APIs, connectors, examples, and templates. Users can discover and use proven assets by the MuleSoft ecosystem, or curate private tenant of exchange with organization specific assets for internal collaboration and learning. As new APIs are created, Exchange automatically generates documentation and maps API dependencies like fragments, connections, and policies. Anypoint platform supports both API, Open API specification (OAS) and RESTful API modeling language (RAML), making API development language agnostic. API providers can also create registration structure that allows the provider to track who is accessing their APIs. After searching for an API or integration asset, the natural next progression is to test portions of API before implementing it in the project. Exchange portal have API notebook snippets embedded within the portal, as well as mocking service integrated directly with Exchange to make testing easy. This allows the user share and test functionality of the API with both internal and external users without implementation, and most importantly without disrupting existing integrations. Once an API portal is ready to share with relevant stakeholders, you can customize your portal to fit your brand. You can change the banner image, color, favicon, and more, so that it provides a seamless transition from your web properties. As a central repository for all technical assets, Exchange also keep track of APIs as they are updated. It is a great place to host information surround the deprecation policy, what circumstances may cause an API to retire, and how to migrate to a new version of an API. In the event that APIs are deprecated, any Exchange sets a banner to notify users about deprecation of a specific API version, and emails all existing consumers of the API to notify them as well. As an example, we can consider to access an organization's public portal. Step 1, navigate to Exchange, then public portal. Step 2, from the developer portal page, select the asset that you want to access. As an example 2, we can consider to publish an API on the portal. Step 1, in Anypoint platform, click API Manager, then in API administration, click an API version of an API. Step 2, on the API version details page, under API portal, select create new portal from the drop down menu. In step 3, on the home page for the portal, edit the text using Markdown. Step 4, click one of the grayed out icons in the center of the canvas to enter text, upload a graphic, or upload the file. For example, click the text icon and enter information about the API that you want to communicate to the portal visitors. Step 5, click the graphics icon to enter a t-shirt graphics. Step 6, use the add drop down in the left pane to add widgets and pages to the site. For example, add an external link, add a navbar heading, click set to visible, add an API reference, API console, setting this page to visible as well. Step 7, click private, toggling the public private control to make the portal public. Step 8, click live portal to see the published portal. Here you can see step 8, click live portal to see the published portal. Here you can see here t-shirt ordering service 1.0 development. As an error example, we can consider this: request access for an API group through public portal is showing resource not found pop-up. The resource you are trying to access could not be located. It was probably removed by someone else. If you think this is a mistake, contact your administrator. There's a request ID here. Now we are focusing on Mule Studio, Anypoint Integration Platform, and Enterprise Manager. Mule Studio, Anypoint Integration Platform, and Enterprise Manager. Now we are focusing on Mule Studio. Anypoint Studio is MuleSoft Eclipse-based integration development environment for designing and testing Mule applications. Here you can see the following quick reference explain the different views you use to build a Mule project. Here you can see the project explorer, view your project structure. Here you can see the canvas, drag and drop building blocks here to create a message flow. Here you can see palette, filter and select building blocks from here. Here you can see properties editor tab, configure attributes of the selected building blocks. Here you can see the console tab. This is the properties editor tab here. This is the console tab, feedback about your app when deploying. So this is Mule Studio. This is regarding this example regarding configuring Mule stack traces. Mule does not display all stack traces by default. When a Mule does show the stack traces, it filters out some internal class references from to produce a readable output. You can control Mule stack trace behavior in two ways. Use command line argument, set properties in Mule Studio. We are considering here set properties in Mule Studio. In Studio, you can set properties to specify to instruct Mule to provide stack traces and filter out packages or classes to remove. To adjust these settings, step 1, select run, then run configurations. Then step 2, define the properties to specify the behavior you want. In this example here, you can see the mule.verbose.exceptions property is set to true. As an example 2, we can consider test your API specification using API console. Studio provides an API console view and a mocking service for the API you are designing. While the mocking service is enabled, the API console view returns the HTTP code status and example payloads that you defined in your API specification. Simulating calls to your API is critical design tasks that help you troubleshoot problems and demo APIs to prospective users even before you implement it. You can simulate calls to API in the API console view before publishing a new version of API specification to Exchange. Studio mocking service does not modify the base URI field in your API specification when it is enabled. There are prerequisites before these steps. You must have API specification project created. Your API specification project must be synchronized with Design Center. You must turn on mocking service. In your package explorer view, right click your API specification project and select API specification, then turn on mocking service. So these are the steps to test your API specification using API console. Locate your API console view within the API design perspective. The API console view displays the summary of your API specification, all the available endpoints and their allowed HTTP methods, a list of all types defined in your API specification. Step 2, navigate through the endpoint section. Click the HTTP method that you want to test and click try it to simulate calls to an API. Your expanded API console view shows the mocking service to the right of the console. Request URL is populated with your selected API endpoint. The request URL field is populated with your selected API endpoint. The use query parameters if you need to add specific parameters to your request. Step 3, click send to send your test request. As an exception example, we can consider this: unable to connect to any database from the Mule Studio Mule Studio. This is occurred in the environment with Anypoint Studio version 7.4 and Mule runtime 4.2.02. org.mule.runtime api.connection exception could not obtain connection from data source. org.mule. The same is repeated here and caused by org.mule. Extension.db.api.exception.connection creation exception could not obtain connection from data source, etc. As an error example, we can consider this one: MuleSoft Studio console error occurred in the environment with Anypoint Studio version 7.9.0. http.listener.10 select runner org.mule.service.http.impl.service.server.grizzly.muless filter SSL handshake error received fatal alert certificate unknown. Now we are focusing on Anypoint integration platform. The MuleSoft's Anypoint platform is a unified single solution for IPaaS and a full lifecycle API management. The Anypoint platform consists of the following major components: Anypoint Security, Anypoint Design Center, Anypoint Management Center, Anypoint Exchange, Runtime Engine and Services, API-led connectivity, Application Network, Data View. CloudHub 2.0 is a fully managed, containerized integration platform as a service PaaS, where you can deploy APIs and integrations as lightweight containers in the cloud. Mule, the runtime engine of Anypoint platform, is a lightweight Java-based enterprise service bus (ESB) and integration platform that allows developers to connect applications together quickly and easily, enabling them to exchange data. It enables easy integration of existing systems regardless of the different technologies that the application use, including JMS, web services, JDBC, HTTP, and more. The ESB can be deployed anywhere, can integrate and orchestrate events in real time or in batch, and has universal connectivity. Here you can see critical components of MuleSoft Anypoint platform. Anypoint MuleSoft Management Center, a unified web interface to efficiently manage all critical aspects of the platform, including but not limited to traffic, service level agreements, SLAs, API users, underlying integration flows, and more. Anypoint connectors offers state of the art tools and assets you need to connect faster. Anypoint Design Center, development tools that make it quick and simple to implement integration flows, design APIs, and build connectors. Anypoint Exchange, a collaboration hub to search for private, pre-built and public reusable assets. Runtime services, an extensive suite of platform services that offer enterprise-grade scalability, security, high availability and reliability. Mule Runtime Engine combines real-time orchestration and application integration with robust data integration capabilities. Here you can see Anypoint Design Center. Within that you can see Studio, API Designer, Connector, Div Kit. And here you can see Anypoint Management Center. Within that you can see Runtime Manager, API Manager and Analytics. Between you can see Anypoint Exchange. Below Anypoint Design Center, Anypoint Exchange and Anypoint Management, you can see runtime services and Mule Runtime Engine. Below Mule Runtime Engine you can see there's Anypoint connectors, and below Runtime Engine hybrid cloud is there. This diagram illustrates the relationship between design tools and other MuleSoft products. Anypoint Design Center includes a web-based tool where MuleSoft developers design and create API specifications and fragments. API Designer. Once your API specification or fragment is ready to be shared with the rest of the organization, you publish it to Anypoint Exchange for testing and approval. This development approach is spec driven. Before moving into API implementation phase, it's crucial to get the sign off from the business and other teams involved. They will test the API returning mock results, provide initial feedback and validate requirements. Anypoint Exchange is a virtual market to share, discover and reuse APIs, connectors, templates, etc. Other part of the design center, Flow Designer, is used to build Mule applications that connect systems into workflows. Here, specification writer uses API designer. The design center consists API designer and flow designer. Anypoint platform consists of design center and Anypoint exchange and API manager. Developer uses Anypoint Studio. Anypoint Studio imports API specification as connectors for Mule apps from API designer. And API Studio imports API specification as connectors for Mule apps from Anypoint exchange. API designer publishes specification and fragments to and imports them from Anypoint exchange. Anypoint designer can create dependencies on assets in Anypoint exchange. Citizen designer uses flow designer. Flow designer imports API specification as connectors into Mule apps from Anypoint exchange. Developer uses API manager. API manager imports API specifications from Anypoint exchange. Here you can see a CloudHub 2.0 architecture. To understand CloudHub 2.0 security and availability, you should understand the architecture behind CloudHub 2.0. CloudHub 2.0 architecture comprises two major components: Anypoint platform services and shared global regions. These two components, along with Anypoint runtime manager, through which you can access them, work together to run your integration applications. Integration applications that you create and deploy to CloudHub 2.0 to perform integration logic for your business. Runtime manager, user interface that enables you to deploy and monitor integrations and configure your account. Platform services, shared CloudHub 2.0 platform services and APIs, which include Anypoint monitoring, alerting, logging, account management, private spaces, secure data gateway, and load balancing. CloudHub 2.0, an elastic cloud of replicas. An elastic cloud of replicas, Mule instances that run integration applications. Here, integration applications. An integration application is any integration that you have built using Anypoint Studio. These applications can do everything from synchronizing data from Salesforce to a database, to publishing a SOAP or REST API, to creating complex orchestration of business processes. Platform services. Platform services are responsible for coordinating all aspects of the platform. They coordinate deployment of applications, monitor integrations, provide analytics data, store application data, run schedule jobs, and more. Many of these services are exposed through the CloudHub 2.0 REST API. CloudHub 2.0 replicas. Replicas are dedicated instances of Mule runtime engine that run your integration applications on CloudHub 2.0. Replicas have following characteristics. Capacity. Each replica has a specific amount of capacity to process data. Select the size of your replicas when configuring an application. Isolation. Each replica runs in a separate container from every other applications. Manageability. Each replica is deployed and monitored independently. Locality. Each replica runs in a specific global region, such as the US, EU, or Asia Pacific. The memory capacity and processing power of replica depends on how you configure it at the application level. Replica sizes have different compute, memory, and storage capacities. You can scale replicas verticality by selecting one of the variables vcore sizes. Replicas within fewer than one vcore provide limited CPU and IO apps with similar workloads can burst to higher CPU speed for short time. This ability helps to improve application startup times and to process infrequent large workloads. Note that application bursting depends on resource availability for nodes and is not guaranteed to occur. If you need consistent performance, use replicas with more vcores. Replica with one or more vcores provide performance consistency. Each replica has a minimum 8 GB storage, which is used for both system and application storage. If your application requires more storage, for example, verbose logging, use a replica with 2 or more vcores, enabling the application to access additional storage in /temp. All applications, including stopped applications, count toward replica usage. To prevent stop application from consuming resources, delete the application. If your applications require more vcores than are available, CloudHub 2.0 allows you to create an application, but you cannot start it until the additional vcores become available. To increase vcore allocation, delete an application or contact your account manager. To increase your subscriptions vcore allocation. Note applications that are stopped till consume vcores as if they were running. The metaspace limit for apps deployed to CloudHub 2.0 is currently 256 MB regardless of the replica size. The initial metaspace size is 128 MB. Metaspace garbage collection begins after the metaspace reaches that threshold. You can scale your applications horizontally by adding multiple replicas for persistent queues. CloudHub 2.0 monitors replicas to verify that they are operating correctly. If you enable automatic restart, CloudHub 2.0 also automatically restart application if necessary. Shared global regions. CloudHub 2.0 provide ability to deploy apps in different regions of the world: North America, South America, the European Union, and Asia Pacific. This global distribution enables you to host your integration in the local closest to your services thus reducing latency. It can also provide for adherence to local laws such as the EU Data Protection Directive for the US cloud and MuleSoft government cloud control planes. MuleSoft hosts the management console and platform services in the United States. For EU cloud control plane, MuleSoft hosts these services in Europe. The region that you deploy your application to determine the domain provided by your application. Load balancer that Cloud 2.0 uses to route request beside in the same region as your application. Here, integration apps are connected to CloudHub 2.0. Runtime Manager interacts with platform services. Platform services consist REST API, Object Store version 2, Anypoint monitoring, logs, alerts, private specs, replica management, and schedule management. Platform services interacts with CloudHub 2.0. Here you can see the graphic. The graphic shows this graphic shows the dedicated Anypoint VPC architecture. An Anypoint VPC is a logically private and isolated network hosted inside the CloudHub. You can connect to a private intranet to your Anypoint VPC as if they were all part of a single private network. The Anypoint VPC configuration exposes the DNS record, Mule worker internal app name .cloudhub.io. This is a DNS A record which includes the IP address of all of your workers, IP addresses of all of your workers. This DNS record cannot be accessed from outside your Anypoint VPC. Each Anypoint VPC allows you to configure firewall rules to check inbound connections directly to your workers. Four firewall rules are created by default. 2 rules that allow your private address space to connect through ports 8091 and 8092, and two rules that allow external request proxies by CloudHub shared load CloudHub's shared load balancer. Through ports 8081 and 8082. All traffics that is not allowed in a firewall rule is blocked by default. Here external intranet interacts with DNS record in VPC. IPsec tunnel VPC peering direct connect is passed back and forth between DNS record and intranet. Here worker app names, workers and firewall rules and DNS records are inside VPC. DNS record is connected to firewall rules and firewall rules are connected to workers here. Here public internet is connected to DNS record in shared load balancer. In the CloudHub you can see shared load balancer and DNS record and VPC. This DNS record is inside shared load balancer and shared load balancer is connected to DNS record here. 8081, 80 HTTP and 82 443 HTTPS pass from shared load balancer to DNS record here, and DNS record here is connected to firewall rules here, and this public internet interacts with DNS record here also. Here this graphic shows the Anypoint VPC architecture with a dedicated load balancer. You can configure a dedicated load balancer inside your VPC, which allows you to provide custom certificates and optionally enforce two-way SSL client authentication. If you configure proxy rules that map your applications to custom domains, you can, for example, host everything under single vanity domain. A CloudHub dedicated load balancer is assigned to a particular Anypoint VPC. A dedicated load balancer then routes traffic to a particular Anypoint VPC within a particular service region of the VPC. Each dedicated load balancer has a DNS A record. It's a IB name it's a LB name dot LB dot anypoints DNS dot net or lb dash name dot l dash lb dash prod dash eu dash rt dot anypoint dns dot net for EU control panel that resolve to two public IP addresses of its two instances. Throughout your DNS provider, you can add CNAME record pointing to the dedicated A record and use your own domain names to access it. This DNS A record can also be reached from outside VPC additionally. Outside VPC. Additionally, a CloudHub dedicated load balancer has an internal domain name to be used by applications and clients within Anypoint VPC. The structure is internal-lb-name.lb.anypoint.dns.net. Here you can see public internet is connected to SSL endpoint, and DNS record and SSL endpoint and other internal DNS. These DNS records are inside dedicated load balancer. Intranet interacts with DNS record here, starting with internal-lb-name, and IPsec tunnel VPC peering direct connect is passing back and forth to and from intranet and DNS record. 2A TLS is passed to and from DNS record to SSL endpoint. Dedicated load balancer and mapping rules, DNS record here, and firewall and workers are inside VPC. Dedicated load balancer is connected to mapping rules. Mapping rules are connected to DNS record here, and 88, 8091, 80 HTTP and 8092 443 HTTPS are passed from mapping rules to DNS record. This DNS record is connected to firewall rules, and firewall rules are connected to workers here. And in the CloudHub, you can see shared load balancer with and DNS record and VPC. This DNS records here in shared load balancer, and 8081, 80 HTTP, 8082, 443 HTTPS are connected to DNS record here. Here you can see a Mule ESB. The key advantage of an ESB is that it allows different applications to communicate with each other by acting as a transit system for carrying data between applications within your enterprise or across in the internet. Mule has powerful capabilities that include service creation and hosting. Expose your host reusable services using the ESB as a lightweight service container. Next point, service mediation. Shield services from message formats and protocols. Separate business logic from messaging, and enable location independent service calls. Next point is message routing. Route, filter, aggregate and resequence messages based on content and rules. Next point is data transformation, exchange data across varying formats and transport protocols. Here business applications, portals, here the Mule transporters and connectors are connected to business applications, portals, rich clients, trading partners, B2B, data resources, and connectivity services, adapters. Mule transports or connectors are connected to Mule integration services, routing, transaction management, transformation, message broker, transportation management, and security are inside Mule integration services. Below Mule integration services, app container is there. It's optional, and with app container you can see Tomcat, WebLogic, WebSphere, JBoss, JTO, Geromino is there. Here you can see the architecture of Mule Management Console. Mule Management Console MMC was deprecated in December 2015. Its end of life is July 2015-2019. This diagram summarizes the architecture of the Mule Management Console. Here the Mule ESB instances monitored by MMC. This can be standalone or embedded instances or clusters. To here the MMC agent contained in the Mule instance, which is responsible for facilitating data transfer between the Mule instance and MMC, applying changes, that is thread pools and configuration file changes to the Mule applications. The number 3, the Mule instance, the MMC instance, the MMC instance, the web-based interface that interact with Mule through MMC agent, JMX function, and next point is JMX functionality exposed by Mule. MMC instance is a web application package as MMC instance is a web application package as a WAR file that execute from within your web servlet container, that is Tomcat, JBoss, etc. Number 4 here, transactional database, that is stored business event transactional data collected by the MMC agent within the Mule instance. This database by default is an H2 database, but you can configure MMC to use other relational databases. Number 5, the environmental database that stores state information about various Mule instances and applications managed by MMC, including alerts, deployments, configuration, etc. The database is by default Apache Jackrabbit, but you can configure MMC to use other relational databases. Number 6, MMC's REST interface, which exposes MMC functionality through a REST API. MMC users can invoke this API to apply MMC users can invoke this API to programmatically Mule instances paired with MMC. Here you can see Mule ESB instances, and you can see MMC agent here within Mule ESB instance. This instance interact, and MMC agent interacts with the MMC web application, the console. MMC web application, the console, is connected to transaction data, business events, environment data. This MMC application, the console, is connected to console interacts with MMC REST API here. Component lifecycle. This is related to developing components. When developing components, you focus on developing code to handle the business logic, not to integrate the component with Mule. For example, if you are developing a component that adds customer data to an invoice, you focus on writing code that queries the customer database and updates the invoice as needed. You do not have to write any special code to handle the message that's passed to the component or to integrate with Mule, as all integration is handled through configuration. You can develop the component as a POJO or as a web service using popular container such as Spring, EJB or Plexus. Component lifecycle. Your component can implement several lifecycle interfaces. The lifecycle flow typically look like this, with the on-call often being replaced by an entry point resolver. Following are the most commonly used lifecycle interfaces. org.mule.api.lifecycle.initializable. This is called only once for the lifecycle of the component. It is called when the component is created and when the component is component pool initializes. With the interface initializable, the initializable is a lifecycle interface that gets called at the initialize lifecycle stage of the implementing service. Here you can see the method initialize. The method is used to perform any initialization work. If a fatal error occurs during initialization, an initialization exception should be thrown, causing the Mule instance to shut down. If the error is recoverable, say by retrying to connect, a recoverable exception should be thrown. There is no guarantee that by throwing a recoverable exception that the Mule instance will not shut down. org.mule.api.lifecycle.startable. This is called when the component is started. This happens once when the service starts and whenever the component is stopped and started either through the API or JMX. The interface startable provides an object with the start method which gets called when the Mule instance gets started. This is mostly used by infrastructure components but can also be implemented by service objects. This lifecycle interface should always be implemented with its opposite lifecycle interface stoppable. And here you can see the method start. Here you can see the interface org.mule.api.lifecycle.callable. Callable is used to provide service with an interface that supports the event calls. Components do not have to implement this interface. Through the onCall method provides an example lifecycle method that is executed when the event is received for the implementing service. Here you can see onCall method passes the event to the listener. And here you can see org.mule.api.lifecycle.stoppable. This is called when the component is stopped. This happens when the server is stopped. So whenever the component is stopped, either through the API or JMX, with the interface stoppable is a lifecycle interface that introduces a stop method to an object. This lifecycle interface should always be implemented with its opposite lifecycle interface startable. org.mule.api.lifecycle.disposable. This is called when the component is disposed. This is called once the server shuts down. And with the interface disposable is a lifecycle interface that gets called at the disposed lifecycle stage of the implementing service as a service is being destroyed. You can see the dispose method here, a lifecycle method where implementer should free up any resources. If an exception is thrown, it should just be logged and processing should continue. This method should not throw runtime exceptions. And here you can see default constructor is connected to initialize is connected to start is connected to on-call is connected to stop is connected to dispose methods. Here this is about as an example we can consider these steps. This is about deploy an application from runtime manager. Here to deploy from runtime manager to CloudHub. Step 1, sign in to Anypoint platform. Step 2, select runtime manager. Step 3, in the application page, click deploy application. Step 4, provide a name for your application. Step 5, in the deployment target menu, select CloudHub if it is not already selected. Step 6, specify the application file. Import a file from Exchange. Click choose file, then import file from Exchange. Select application for the type, then enter the name of your application in the search box. Select the application to deploy. Select a version from the version menu and then click select. Next point, upload an application archive, zip or jar file. Select choose file, upload file. Select the file to upload and then click open. The application file size limit is 200 MB. Next point, copy an application from a non-production environment. Step 7, click tabs to configure application options. Step 8, click deploy application. Here you can see the step 3. In the application page, click deploy application. This is the deploy application page. You can this screenshot shows one here, the application name field, to the choose file menu, and 3, the deploy application button on the deploy application page. As an example 2, we can consider this code segment. This is CloudHub connector 1.0 Mule 4. This is a minimum CloudHub configuration. The Anypoint CloudHub connector for CloudHub connector enables you to connect to a CloudHub API from your Mule application. The basic CloudHub configuration has following properties: username, the user of the Anypoint platform account, password, the password of the given user, and the environment, the CloudHub environment used by default. This is the environment defined as the default Anypoint platform. As an example 3, we can consider this CloudHub API example. This following example shows how to retrieve schedules for an application. The CloudHub API, the CloudHub public API allows you to deploy and manage application in CloudHub. You can deploy your application manage schedules and queries within an application, and view logs pertaining to an application. You can also view memory and CPU usage and get statistics about Mule messages sent using application. This is the request. And this is the response. As an example 4, we can consider this code segment. Following is an introduction to configuring Mule ESB via the Spring XML file. Following is an example of a simple Mule configuration file. A Mule ESB configuration file is a tree. Each of these elements provide access to configuration objects within Mule. Custom message processors observe a message or modify either a message or a message flow. Example include transformers and filters. Flows use message processors to define message flow between source and target. Mule global configuration, global settings such as default transaction timeout that apply to the entire Mule configuration. Connectors, non-default configuration of any transports use. Endpoints, define the channel and address or path where messages are sent or received. You can define them globally and use them in multiple flows. Transformers, convert data from one format to another. You can define them globally and use them in multiple flows. Filters, filter out the messages that don't match specific criteria. You can define them globally and use them in multiple flows. And other more advanced things you may configure at this level is Security Manager authenticates requests based on one or more security providers. Agents are typically used for cross-cutting concerns such as logging or management. Notification allow you to be notified upon certain lifecycle events. Transaction management, Mule transactions are configured in inbound on inbound endpoints, or where an endpoint can be configured to start a new transaction or join existing one. Properties, property placeholders, message property, system, and system properties. There are configurations in Mule configurations are set when Mule context is created. The object becomes immutable after it is started and can be accessed using following, like here get configuration. Interface Mule configuration info, which can be set when creating the Mule context, but becomes immutable after startup. This is in package org.mule.api.config, and this is implement Mule context aware to have the reference injected. As an exception example, we can consider this one. This is occurred during our API call curl -x get /https any / anypoint.mulesoft.com /cloudhub /api /applications /supported Mule versions here -h authorization bearer, and with then 16E6 etc. The root exception stack trace com.mule.mulesoft.cloudhub.client cloudhub exception forbidden at etc. As an example 2, we can consider this error while deploying the project: unable to create plugin from class com.mulesoft.muleesb.datamapper.plugin.datamapper plugin org.mule.api.lifecycle.initialization exception. And etc. As an error example, we can consider this error occurred in the environment with Anypoint Studio. Deploy to CloudHub application deploy has failed. Recent application deploy has failed. As an error example 2, we can consider this build failure in the environment with Anypoint Studio 5.2.0 and Mule ESB 3.0. 3.70. Warning: the POM for COM46 MuleSoft 46 Mule ESB Mule core EE jar is missing, no dependency information available. Warning: the POM for COM etc. the modules Mule module spring config jar is missing, no dependency information available etc. Here this we can consider as an error example 3. We can consider this code segment. Expect an error in your test. The key is taken from the payload. And if the key is null, the object store connector will throw an error with OS invalid key error type here. To the test to validate this case would be something like this here. The here the Munit 2.3. The Munit is a Mule application testing framework that allows you to easily build automated tests for your integrations and APIs. It provides a full suite of integration and test unit capabilities and fully integrated with Maven Surefire for integration with your continuous deployment environment. Now we are considering Enterprise Manager and Insight. Enterprise Manager. Insight is a troubleshooting tool that provides in-depth visibility into business transactions and events on your Mule apps deployed to CloudHub and on-premises servers. Insight tracks everything your data does in an app, so you can find and recover from errors that occur during message processing. Following image shows where to find transactions, events and metadata. Events and metadata on Insight dashboard. This screenshot shows now the transaction level, 2 the event level, and 3 the metadata level on the Insight dashboard. With regard into search and filter transactions and events, the Insight dashboard displays the information at 3 tracking levels. The first point is transaction, logical groupings of related events that often correspond to a business view of the system. Events, low-level details of a transaction. Events map to message processors and endpoints and reveal information about exceptions and any custom business events you might have configured. Metadata, customized key value pairs that you specify as part of custom events in your application. The details that Insight tracks at this level provides information about high-level business events. The business data, if configured, appears in metadata area number 3 here of the dashboard. As an example, we can consider this. This is how to disable business event on Insights. When you enable Insight in your CloudHub application, all business events from all flows are going to be tracked by default. You may not want to track events from certain flows. For example, one that is not totally related with the business event you want to track. If you do not want to track the business events from example flow 2, with an ID, we have to add the property tracking : enable default events equal false to the flow declaration here. Now the only the business events from example flow 1 are going to be tracked, and that is not shown here. That flow is different. As an example 2, we can consider how to enable Insight via the CloudHub API. The response should be here, and here the objective of this is to show how to use CloudHub API in order to enable Insight in a Mule app on a Mule application. Here with this command, especially here the app name being the relevant application name, and envid and bearer token, the information gathered. And this is a put request. The response should be HTTP 200 OK, and you should see the response body that tracking settings attribute here was changed from previous from the tracking setting attributes is tracking level : is metadata. The nested tracking level attribute is used to set the level. Valid values are disabled metadata, and metadata underscore and underscore replay. To enable or disable Insight, to enable Insight to track the events your Mule servers generate, you should follow these ones. Step 1, sign into your Anypoint account, Anypoint platform account. Click Runtime Manager. Step 3, click Applications in the menu on the left and click Application in the menu column to open the management panel on the right side of the page. Step 4, in the management panel, click Insight. Step 5, click Settings in the menu on the left and then click the Insight tab. Step 6, select one of the tracking options, disabled to disable Insight, metadata to track only events, metadata and replay to track events, and enable ability to instantly replay a transaction from the console. The metadata and replay option is available for Mule 3 apps with flows that have inbound endpoints deployed to CloudHub. This option is unavailable for Mule 4 apps or for free or trial user accounts. Step 7, select the checkbox to confirm that you want to enable Insight, then click Apply Changes. And step 8, click Apply Changes to save the application settings. This is step 4, click Settings in the menu on the left and then click Insight tab. The arrow shows the Insight tab on the settings page. Here you can see tracking options, disable to disable Insight, and metadata to track only events, and metadata and replay to track events, and enable the ability to instantly replay the transaction from console. As an example, 4, we can consider status stalled. The event has been put on hold due to an exceeding the maximum number of events to be processed per transaction, 10,000. Any event above this number is set as stalled and then processed after the number of events to be processed is no longer exceeded. As an exception example, we can consider status failed. The event failed while being processed and has an associated exception. As an error example, we can consider Insight service unavailable. Please try again later. When trying to enable Insight for a hybrid deployed application, this error occurred, and this is in the environment with Runtime Manager. Now we are considering Anypoint Service Registry, now part of API Manager. Built for the new Enterprise Anypoint Service Registry is SOA, a governance platform that ensures compliance with internal standards and best practices as well as regulatory mandates. Moreover, Anypoint Service Registry make it easy to manage and monitor services, keeping you apprised of the performance and usage patterns of all of your services. You can focus on innovation and optimization and not governance. As an example, we can consider this code segment, storing objects in the registry. Here you can see this produce the interface get registry provide interface Mule registry, adds lookup register unregister methods for Mule specific entities to the standard registry interface. This is in Java, and this is in package org.mule.api.registry. And if you need to store runtime data that is available across the application, you can store data as objects in the registry. You can get a handle to the registry from anywhere that you can access the Mule context as in the Mule entities. So for example, you can store objects as follows here. As an error example, we can consider this error occurred in the environment with Mule core endpoints 3.4.0, deploying application key issue test, reading plugins from C:\Mule/Mule Studio for Win, etc. And here also registry plugin Anypoint, and here you can see com.mulesoft.habitat.agent.anypoint agent utils :anypoint service registry agent is disabled property anypoint.agent.token is missing or empty, and etc. Now we are focusing on SAP SE. Is a German multinational software company based in Waldorf, Baden-Württemberg. It develops enterprise software to manage business operations and customer relations. The company is the world's leading enterprise resource planning software vendor. SAP is the largest non-American software company by revenue, the world's third largest publicly traded software company by revenue, and the second largest German company by market capitalization. Apart from ERP software, the company also sells database software and technology, particularly its own brands, cloud engineered systems, and other ERP software products such as human capital management, HCM software, customer relationship management, CRM software, also known as customer experience, enterprise performance management, EPM software, products lifecycle management, PLM software, supplier relationship management, SRM software, supply chain management, SCM software, business technology platform, BTP software, and programming environment, SAP AppGyver for business. As an example, we can consider this XML for sending IDOC and sending an IDOC to SAP. Paste this code into the new Mule app in Studio to quickly load the flow for the sending an IDOC example. Change the values to reflect your environment. SAP connector 5.6 here, 6 Mule 4 here. The Anypoint connector for SAP connector enables the integration for data and to and from external systems based on SAP NetWeaver. As an example too, we can consider this: add the connector to your Mule project. Add SAP connector to your Mule project to automatically populate XML code with the connector's namespace and schema location, and to add required dependencies to the project's pom.xml file. Adding a connector to a Mule project in Studio does not make the connector available to other projects in your Studio workspace. These are the steps. Step 1, in the Mule palette view, click search in the exchange. Step 2, in the add dependencies to the project window, type SAP in the search field. Step 3, click SAP connector in available modules. Step 4, click add. Step 5, click finish. As an example, we can as an exception example, we can consider this one, the timeout exception. This timeout exception happen inside the jcore library, SAP colon timeout here. Here we can consider, as an error example, we can consider this one, missing jcore native library. Here you can see java.lang.exception initialize error. This is a jcore initialization failed with java.lang.unsatisfied link error colon no SAP jcore in java library.path here, and you can see here the test failed, connection failed, error tying to test connection. Report this incident. Reason: java.lang.exception initialize error, jcore initialization failed with java.lang.unsatisfied link error, no SAP jcore 3 in java.library.path here. Now we are focusing on Oracle. Now we are focusing on Oracle. Oracle Corporation, formerly Software Development Laboratories, Relational Software Incorporation, and Oracle System Corporation, global corporation that develops and markets computer software applications for business. The company is best known for its Oracle database software, a relational database management system, and for computer systems and software such as Solaris and Java, acquired in its purchase of Sun Microsystems in 2010. Oracle is based in Redwood Shores, California. Here you can see the integration architecture of the MuleSoft Oracle EBS connector. The Oracle EBS offers different technologies or products to address various types of integrations. The most widely used integrations for enterprise applications are data-centric integration. The next one is integration through web services using Oracle e-business suite. E-business suite integrated SOA gateway, ISG. Here you can see Oracle EBS 12.2 connector is inside Mule application. This Mule application is Mule application interacts with other external applications here, and Mule application interacts with Oracle here. And web service call is passed from Mule application to Oracle, and Oracle web service response is passed from Oracle to Mule application. Inside the database, PLSQL APIs, integration repository, and integration repository are inside Oracle, and database interacts with PLSQL API and integration repository here. And here you can see the Oracle e-business suite. Here that the Oracle e-business suite 12.2 connector Mule for the Anypoint connector for Oracle e-business suite 12.2 EBS 12.2 connector facilitate connection between Mule runtime engine, Mule integration, and Oracle e-business suite 12.2 applications. Here you can see use case XML in Oracle e-business suite 12.2 connector Mule 4. As an example too, we can consider add connector in Studio here in Oracle eBusiness Suite 12.2 connector Mule 4, and you can also add the connector using Exchange. Here we are considering add the connector in Studio. Step 1, Studio. In Studio, create a Mule project. Step 2, in the Mule palette view, click X search in Exchange. And step 3, in Mule, add modules to project, type EBS in the search field. Step 4, click the connector's name in available modules. Step 5, click add. Step 6, click finished. As an example 3, we can consider parameter connection. Connection types for this configuration here. Type PLSQL. This is in Oracle eBusiness Suite 12.2 connector Mule 4. As an exception example, we can consider this occurred in Oracle EBS connector. Here you can see the links href equal https etc, and this is d2rlvs 3d 9006 ap.cloudfront.net/s3_images/1242474/ebs_connector _0.1.png and etc. And you can see here java.lang reflect.undeclared throwable exception at com.standard.proxy and etc. And here at org.mule.modules.oracle.connection manage multi-strategy.test connectivity etc. And we are focusing on IBM in full international business machines corporation, leading American computer manufacturer with a major share of the market both in United States and abroad. As an example, we can consider this one to publish messages. Here, sending a message to a queue. Here the IBM MQ connector Mule 4. The IBM MQ connector version 1.6 Mule 4. Anypoint connector for IBM MQ. IBM MQ connector enables an app to do messaging to a IBM MQ broker using IBM MQ JMS implementation. The main features include pub sub pattern support for any given destination, listen reply pattern support for any given destination, publish consume pattern support for any given destination with fixed or temporary reply queue, non-blocking publishing and consumption messages. Here, when used in its default form, the connector will publish whichever is in the payload. But what happens if the payload is not in the correct format and you need to make a transformation? You could place a data wave transformation before publish operation, but that would cause the message payload to change and impact the operation placed after publish operation. To avoid this undesired impact, you can now place the transformation inside publish operation. Now the transformation can be used for generating the content that will be published without producing a side effect on the message in transit. This is as an example too, we can consider related to publish messages, publishing a message to a topic. This is a IBM MQ connector Mule 4, IBM MQ connector version 1.6 Mule 4, Anypoint connector to IBM MQ. IBM MQ connector enables and app to do messaging to an IBM MQ broker using IBM MQ JMS implementation. The main features include pub/sub pattern support on the given destination, listen reply pattern support for any given destination, pub consume pattern support for any given destination with fixed and temporarily reply queue. Non-blocking publishing and consumption of messages. The publish operation can also be used to publish message to a given topic destination. All configurations of the operation and message are identical, but the destination type here, destination type parameter has to be declared as a topic destination. For the same example seen before, if instead of sending the message to the queue, we want to publish it to the topic, and here we will do here. As an example 3, we are considering connection modes. Here we are considering client connection configuration on XML. This other mode is binding connection mode. Here the IBM MQ connector version 1.6 Mule 4. The client connection mode lets you to connect to the IBM MQ manager running on this in the same system that is being run in the Mule application or in other system. In both cases, IBM MQ connector will connect to the IBM MQ manager over TCP/IP. For this connection mode are available for the following configurations. Host, this is a required parameter. The host containing the IBM MQ broker. The port default value is 1414. The queue manager listener port. Queue manager. The queue manager used when selecting a channel definition. Channel, name of the channel to connect to, dev.admin.svrcon. Connection name list, host to which the client attempts to reconnect after its configuration is broken. The connection name list is a comma separated list of host and IP pairs. Here you can see the client connection configuration on XML here. Here we are considering at the connector in Studio. Here we are adding IBM CICS transaction gateway connector, Mule 4. IBM CICS transaction gateway connector version 2.3. Anypoint connector for IBM CICS transaction gateway, IBM CTG connector, provides integration with backend CICS apps using CICS transaction gateway. For Java platforms, CTG implementations implements the Java cryptography architecture, JCA resource adapter to connect Java applications to the customer information control system, CICS system. The connector serves as a link between Mule apps and the IBM CTG. Here, step 1 in Studio, create a Mule project. Step 2, in the Mule palette view, click search in Exchange. Step 3, in add modules to project, type CTG in search field. Step 4, click this connector's name in available modules. Step 5, click add. Step 6, click finish. As an exception example, we can consider this one: fail to deploy. This is occurred in IBM CTG connector. Fail to deploy artifact IBM CTG connector. See below, and org.mule.runtime module.license.api.exception.invalid license exception. Runtime license does not contain entitlement IBM CTG connector required by plugin IBM CTG. Now we are focusing on custom apps. You can add your custom Mule module to your Mule projects in Anypoint Studio. As an example, we can consider this code segment, this segment here. In your Anypoint Studio project, edit the pom.xml file with the group ID, artifact ID, with the group ID, artifact ID, and version of your Mule module. This information is available in your Mule's pom.xml file, for example. It is also reflected in the folder structure in which the Mule module was installed. $maven underscore rep underscore home / group ID underscore path and artifact / artifact ID / version. As an example too, we can consider adding custom modules to a project. You can add your custom Mule module to your Mule projects in Anypoint Studio. These instructions assume that you coded your Mule module using the Mule SDK and that you followed the proper setup steps. Mule modules are developed by as Maven projects. Therefore, your custom Mule module must be installed in a local or online Maven repository. Here in step 1, in your Anypoint Studio project, edit the pom.xml file with the group ID, artifact ID, and version of your Mule module. And step 2, save your changes to your Studio project's pom.xml file. After Anypoint Studio downloads the new dependency, you will see your new Mule module in the Studio palette. Now we are focusing on database. Database, also called electronic database, any collection of data or information that is specially organized for rapid search and retrieval by a computer. Databases are structured to facilitate the storage, retrieval, modification, and deletion of data in conjunction with various data processing operations. A database management system, DBMS, extract information from the database in response to queries. As an example, we can consider this segment. In the configuration XML editor, the db:select configuration looks like this. Here the database connector 1.13 Mule4 Anypoint connector for database connector establishes communication between your Mule app and a relational database. Database connector can connect to almost any Java database connectivity, JDBC, relational database, and run SQL operations. An application can support multi-tenant scenarios using the same configuration element, changing the connection attributes based on, for example, information coming from each request. To add and configure the select operation in Studio, follow these steps. This is under database connector 1.13 Mule4. Step 1, in the Mule palette view, search for the database and select operation. Step 2, drag the select operation into Studio's canvas. Step 3, in the general tab of the operation configuration screen, click the plus sign next to the connector configuration field to access the global element configuration fields. Step 4, specify the database connection information and click OK. Step 5, set the SQL query text field to the SQL query to execute. For example, select asterisk from planet where name equal colon name. Here you can see the step 5. Set the SQL query text field to execute to the SQL query to execute. For example, select asterisk from planet where name equal colon name. As an example 3, we can consider this. When you configure a database connection, Anypoint connector for database connector can connect to any database for which JDBC driver is available. Here configuring data source reference connection. The database connector generate a JDBC's data source by using the parameter values you provide when you configure the generic connection field. If you want to create your own data source and use it to connect a database, configure the data source reference connection field. So this example shows how to use Anypoint Studio to configure a data source reference connection to a Derby database. Here, step 1 in Studio, in the source src/main/resources folder, create a data source config.xml bean file to define a custom nhydra data source that connects to a Derby database. Step 2, return to your Mule flow. Go to the global element view and click create to open the choose global type window. Step 3, in the filter field, type Spring, select Spring config and click OK. Step 4, in the Spring config window, files field, add data source config.xml to reference the Spring configuration file with the Spring module. Step 5, click OK. Step 6, in the global elements view, click create to open the choose global type window. Step 7, in the filter field, type database, select database config and click OK. In step 8, in the database config window, for the connection field, select data source reference connection. Step 9, click config to add the required JDBC driver and select either use local file, install the library using local file, add Maven dependency, install a Maven dependency to add to the project. Step 10, for data source ref, add the bean ID JDBC data source created in the data source-config.xml bean file. Step 11, click test connection to confirm that Mule can connect to the database. Step 12, click OK. Here the step 1 in Studio, in the source src/main/resources folder, create a data source .xml bean file to define a custom nhydra data source that connect to a Derby database. Here you can see data source config.xml file contents. Here in step 5, click OK. This is a Spring configuration data source. Here the step 12, click OK. This following screenshot shows the configuration. This is the data source reference connection. And here you can see in the XML editor both Spring and database configurations look like this. As an exception example, we can consider this one, java.sql exception cannot get connection for URL jdbc : SQL server : /10.11.12.13.:1433 database name equal some db and user, some user password, some password. The TCP/IP connection to the host 10.11.12.13 port 1433 has failed. Error connect timeout. Verify the connection properties. Make sure that the instance of SQL server is running on the host and accepting TCP/IP connections at the port. Make sure the TCP/IP connections to the port are not blocked by a firewall. org.mule.db.internal.domain.connection creation exception. Message payload is of type string. As an error example, we can consider this error: org.mule.retry.notification.connection notifier failed to connect /reconnect /JDBC connector. Here you can see the name JDBC connector, lifecycle initialize this, and number of current transaction receivers 4, etc. Connected false. And root exception was cannot get connection for URL jdbc : postgres SQL : /xxx, etc. Now we are focusing on JMS, the Jakarta Messaging API, formerly Java Message Service, or JMS API, is a Java Application Programming Interface API for message-oriented middleware. It provides generic messaging models able to handle producer-consumer problem that can be used to facilitate the sending and receiving of messages between software systems. Jakarta Messaging is a part of Jakarta EE and was originally defined by a specification developed at Sun Microsystems before being guided by the Java community process. Here you can see the point-to-point message delivery mode. In this type of messaging, exchange of messages happen between a single sender, producer, and a single receiver, consumer, via a queue. Once the sender publishes a message, it is retained in a queue until a receiver consumes that message. This diagram shows this delivery mode, and here you can see client 1 is connected to message and it is send, and message is connected to queue. And here you can see the client 2 is connected to queue and consumes is passed from message 2 to queue, and acknowledges are passed from client 2 to queue, and this is messages consumed. Here you can see publish subscribe mode. Here we can have multiple receivers that receive the same message simultaneously, given that they have subscribed to the message broker via topics. When a message is sent, the topic publishes to all the subscribers and retains it until it is consumed. A subscriber can be durable or non-durable. The messages are stored persistently for a durable subscriber, and can be recovered if the message broker fails. However, for a non-durable subscriber, the message are not stored. So no message is delivered if the consumer connection is lost. This diagram shows the publish, subscribe, delivery mode. Here you can see client 1 is connected to message, and message is message publishers, and message is connected to topic. Topic interact with client 2, client 3, and client 3. Delivers is passed from topic to client 2, and subscribes are passed from client 2 to topic, and here delivers are passed from topic to client 3, and subscribes are passed from client 3 to topic, and you can see the message here. Here you can see publish, subscribe, and point to point. Here you can see queue. Typical use cases, this is work distribution. Number of connected consumers allowed 0 or more. Who receive the message? Only one receiver. If no active subscribers, message persists. This is topic. Typical use cases: one-to-many broadcast. Number of connected consumers allowed 0 or more. Who receive the message? Who receives message? All active subscribers. If no active subscribers, message dropped if subscriber is not durable. Here you can see publish and subscribe one to many. This is publisher is connected to topic, and topic is connected to subscribers. Here you can see point to point, one to one. Sender is connected to queue, and queue is connected to the potential receiver. Here we are considering publish messages using JMS connector. Here publish message to a queue. In this example, you configure the operation to publish message to a queue specified in the destination field. In the JMS connector 1.8 Mule 4, Anypoint connector for JMS Java message service, JMS connector enables sending and receiving messages to queues and topics for any message service that implements the JMS specification. JMS is widely used API for message-oriented middleware. It enables the communication between different components of a distributed application to be loosely coupled, reliable, and asynchronous. The main features of JMS connector include publish and subscribe pattern support on any given destination, listen and reply pattern support on any given destination, publish and consume pattern support on any given destination with a fixed or temporary reply queue, fully compliant with JMS 2.0, 1.1, and 1.0.2 specification. The publish operation publishes whatever it is in the message payload to the specified queue. Here you can see you configure the operation to publish a message to a queue specified in the destination field. Step 1, in your studio flow, select publish operation. Step 2, set the destination field to the queue name, for example invoice queue. With the here you can see step 2, set the destination field to the queue name, for example invoice queue. This is publish operation configuration to a queue. In the XML editor, the JMS publish and destination configuration look like this. As an example too, we can consider publish the message to a topic. The publish operation can also publish the message to a specified topic destination. Because all the configurations of the operation and message are identical, you just need only to configure destination type to topic. In this example, you configure the operation to publish a message to a topic destination. Step 1, in your Studio flow, select publish operation. Step 2, set the destination field to the queue name. For example, publish operation configuration to a topic destination. Image topic destination. The publish configuration is screen. Set the destination type to topic. Here in the description there should be an image, and this is neglect this part here. Yeah, it's modified. And here you can see in the XML editor the JMS publish and destination type configurations look like this. As an example 3, we can consider add the connector to your Mule project. Add Anypoint connector for JMS connector to your Mule project to automatically populate the XML code with the connector's namespace and schema location, and to add the required dependencies on the project's pom.xml file. This is under JMS connector 1.8 Mule 4. Step 1, in the Mule palette view, click search in the Exchange. Step 2, in the add dependencies to project window, type JMS in the search field. Step 3, click JMS connector in available modules. Step 4, click add, and step 5, click finish. Adding a connector to a Mule project in Studio does not make that connector available to other projects in your Studio workplace. As an exception example, we can consider this occurred in the environment with Mule Server 3.9.0 and JBoss ActiveMQ server. org.mule.module.launcher deployment start exception, connect exception : connection refused, connect at org.mule.module.launcher.application default Mule applications start, caused by JMS caused by javax.jms.jms exception, could not connect to broker URL, reason java.net.connect exception, connection refuse, connect, etc. As an error example, we can consider this one. The org.mule.runtime.co.internal.exception.onError propagate handler message. An error occurred while listening for the reply from the queue. Test queue failed to retrieve a message, operation timeout, failed to retrieve a message, operation timeout, and error type JMS : timeout. This is the element here, and other informations are here, and etc. Now we are focusing on file. A computer file is a computer resource for recording data in a computer storage device, primarily identified by its file name. Just as words can be written to a paper, so can data be written to a computer files. Files can be shared with and transferred between computers and mobile devices via removable media networks or internet. As an example, we can consider this one. This example read file using file configuration and relative path. The file connector 1.5 Mule 4 Anypoint connector for file connector manages files and folders on a locally mounted file system. The connector's main features include ability to read files or fully list directory contents on demand, support for common file operations such as creating directories, reading, writing, copying, moving, renaming, deleting and listing files, support for locking files, file matching functionality, design that is consistent with FTP connector and SFTP connector. Using Anypoint connector for file connector, the transport can read a file at any point in the flow rather than only as a result of inbound endpoint polling in the Mule 3 implementation. The only required parameter for the read operation is the path to the file to be read. The path can be either full path to the file or relative path. The path uses the working directory value defined in the configuration reference by the config-ref parameter. In Anypoint Studio, you can set the path in the file path field, and XML use the path attribute file read statement to specify the path. If no configuration is referenced, the working directory default to the value of the user.home system property. If the system property is not set, the connector fails to initialize. This example reads a file using the file configuration and relative path. Here, this is example. As an example, we can consider this. This is in data view. This uses read URL to read JSON content from your file. DataWave 4.4 here. DataWave is a programming language designed by MuleSoft for accessing and transforming data that travels through Mule applications. Mule runtime engine incorporates DataWave in several core components like transform and set payload, and which enables you to execute DataWave scripts and expressions in your Mule app. As an example 3, we can consider using Anypoint Studio to configure file connector 1.5 Mule 4 at the connector to your Mule project, at the file connector to your Mule project to automatically populate XML code with the connector's namespace and schema location, and add the required dependencies to the project pom.xml file. Step 1 here, in the Mule palette view, click Xsearch in the Exchange, and in the add dependencies, step 2, in the add dependencies to project window, type the file to search field, and in step 3, click file connector in available modules, and step 4, click add, and step 5, click finish. As an exception example, we can consider this one occurred in the environment with file connector. org.mule.api.default mule exception, failed to move file source file to destination file. The file might already exist. As an error example, we can consider throw file illegal underscore path in the environment with file connector. This is the create parent directory property is set to false, and neither the target path nor its parent exist. This is the end of my presentation. Thank you very much for watching it.